Assalamualaikum, nama saya Muhammad THOHA HUSSAINI bin Nasir.
Selamat pagi, nama saya Yakin.
Hai, nama saya Lee Hong.
Salam sejahtera and a very good day to our lecturer Dr. Zahir. Today our team from class 3 BMKA section 2-1 are going to have a presentation and discussion on lab sheet based on the topic design and analysis of car disc brake system. So before starting the design process, we are just going to take a look on the procedure. So first thing first, we are given the task to design a disc brake based on the diagram given and dimension given. Then later on, we are going to put on the correct material properties on the completed disc brake. And then lastly, also the ultimate goal for this lab sheet is to having a structural analysis on the disc brake, where we are going to put on a distribute force on our disc brake, and then we'll let the software to calculate and run the result. Then for the gaining result, we'll just put on the table given, and then done with some calculation. Okay, so this is our team disc brake. This is the completed disc brake. So for this session, I'm just going to have a short and quick brief on the designing process. So first thing first, we always start with the basic sketch for our item. Okay, so this is a basic sketch. We apply with the correct dimension, and then the correct concept of our basic of disc brake. Okay, so later on, after the basic sketch, we extrude the basic sketch into a 3D shape. Okay, so later on we start to design the built-in hole, which is this one. We start with the basic sketch for our built-in hole, and then later on we apply groove feature over here. Okay, to make it look like a built-in hole completely. So later on, we apply the circular pattern to let the software to put the designed hole all over the disc brake correctly with the correct angle set. Okay, so for the next step, we design the hole for the bolt and nut to apply. So we put on the correct sketch and the correct dimension, and then later on we pocket it on the surface of the disc brake. And then also with the same feature, circular pattern, we copy and paste the hole for bolt and nut just now. We put it all over on the disc brake surface correctly. Okay, so for the next sketch is about the holes over here. So this is some fancy feature of our team's disc brake to make it look more real, more realistic, to match with the modern disc brake nowadays. Okay, so this is the basic sketch for the holes, and then later we pocket it on the this brake surface. Then later on, with the same feature, circular pattern, we put it all over on the this brake surface correctly with the correct angle set. Okay, so for the next part is about the brake pad. First, we just have to sketch the basic shape of the brake pad, and then we give the dimension correctly, and then later we just extrude the brake pad on the disc brake surface. So this is for the front brake pad, and then here is the rear brake pad. Okay, so after done designing the disc brake, we just apply the correct material on the disc brake. So the apply material, we can just click on here and then select the material desired, then just click apply material and click OK. Okay, so next for the structure and analysis section, we can just click on the start over here, and then we can just select this generative structural analysis. Okay, so to start with the analysis, there's a few setup we have to done. So first, we just clamp on the surface of our disc brake. Okay, so next we apply this surface slider on the surface of our disc brake. Then next we apply the correct distribute force on our brake pad with the correct direction set, and this one is for the rear part. Okay. Later on, for the next thing is we need to apply rotational force. So for the support, we'll just select the whole body of our disc brake, and then the rotational axis, we'll just select the edge over here. Okay, and click on correct. Okay, so after done for the setup, we can just click calculate. We'll just let the software to compute and calculate all the value needed. Okay, after done calculating, we can just have a different look of our disc brake. It's a different state. Okay. Okay, so later on, we will just insert this frequent case for our disc brake. So for the reference part, we'll just select this static case solution. Then we just click OK. Okay. So later on, we'll just let the CATIA software to compute again. Okay, so for this time, yes, this is the result we are looking for. So we can just look at the result value over here, and then this one is for the von Mises stress. Okay, to look on the animation, we can just click on the animation option over here, and then we can see our disc brake rotate. Salam sejahtera and good day to our lecturer, Dr. Zahir. So today our group are going to have a discussion about the lab sheet 1, which is the topic design and analysis this break. So this is the data or finding we have gained after designing our this break. So what we can see from here is the Young modulus after the calculation from the software CATIA. So the Young modulus is for our disk break is 2 uh, times the 2 times 10 power 11, where the unit is Newton per meter square. And then the second one is the Poisson ratio, which is 0.266. The density is 7,860. The unit is kilogram per meter cube. And then the fourth one is the thermal expansion, where the value is the 1.17 times 10 to the power of negative 0.005, where the unit is Kelvin degree. And the fifth one is yield strength, where the value is 2.5 times 10 to the power of positive 0.008, where the unit is Newton per meter square. And then the last one is the material, where the material of our disc brake is steel. Okay, so this is the structural analysis result for our disc brake. The von Mises stress, and then also the translational displacement. So this is the result from the previous picture. So where the maximum von Mises stress is 3.24 times 10 to the power of positive 0.011. And then where the unit is Newton per meter square. And then the second one is the minimum von Mises stress. The value is 2.19 times 10 to the power of 8. And then where the unit is Newton per meter square. And then the last one is the translational displacement. The values is 337 and the unit is millimeter. So for the factor safety, I will pass it to my teammate Lee.
So, so to calculate factor of safety, we use the formula provided from the sheet, which is safety factors equal to ultimate stress, torque mass, divided by allowable stress, torque W. The value we get from the ultimate stress is 2.5 times 10 power of 8 Newton per m 2. And the allowable stress is 3.24 times 10 power of 11 n over meter power of 2. Okay, so for the answer of the calculation, we can get the answer for the safety factor is 7.7 times 10 negative 4. Next. So for the discussion, based on your result, we discuss about von Mises stress and factor of safety. So the result revealed that the rotor brake is not structurally sound under the stimulated loading condition. The von Mises stress exceeds the yield and ultimate strength of the material, indicating that the disc is subject to excessive loading and is likely to experience plastic deformation or catastrophic failure. And for the safety factor of 0.00077 is significantly lower than the recommended value for engineering component, which typically range from 1.5 to 3 or higher, depending on the critical of the component and the level of uncertainty in the analysis. This indicates a high risk of failure for the rotor brake disc under the given loading condition. Next. And for the conclusion, the rotor disc was analyzed to evaluate its structural performance, and under the application of braking force using CATIA V5 software, it is important to evaluate both stress and the factor of safety in rotor brake disc design. The current materials and design parameters are inadequate to handle the operation loads leading to a failure scenario, where a redesign is necessary based on optimizing material selection, design geometry, and load distribution to achieve a safe and reliable brake disc system. Okay, that's all from us.